All right. Hello, everyone. Sorry, I'm slightly late today. I was just wrapping something else up and that took just a few more minutes. So, this is going to be another coding live stream. It should be a pretty easy one, but then again, every time I say that, I just get random surprises and nothing quite goes as scheduled. So, we'll see. The idea for this one is to tackle one of our easy issues here. So if we go look at the list of open issues against Incus, there is one here for supporting virtio-blk alongside both virtio-scsi and NVME, which are currently supported. This should be hopefully straightforward because virtio-blk supports connecting to the PCI bus, which means it should be near identical to the NVMe support. But again, not really tested, so it's going to be interesting to see if that actually behaves that way. Just before doing that, I just noticed that we've got a small test failure here, which is just bad coding, I think. It shows it's our code test, which is what does static analysis, and it's just complaining about a misspelling. So why not go and fix that real quick? So I'm just checking off screen what branch I'm in right now, making sure everything is good here before going into VS Code to look at this one. So looks like we're okay. Yeah. All right, so the test just says there's a typo line 189 in shared ID map. Somehow I missed it when the pull request went up, so anyway, it's an easy fix. Where did I put VS Code? There. So let's close this stuff, and it's actually a bit of a leftover thing from last week for anyone who looked at, who watched that stream. Last week I did a tiny bit of tweaking in the shared ID map package, specifically adding what was needed for the Incus user daemon to check ID maps correctly. After that, I went a bit crazy and kind of rewrote 3/4 of the ID map package, and I think it's part of that rewrite where I introduced a typo. So it's in set.go 189. Okay. So set.go and go down to 189. Here we go, 189. Splits the lower part of the entry. IDs. Oh yeah, there's a missing N here. Just checking that there's no complaining about anything else. It is not. Okay, cool. Well, that's an easy one. So just save that. Do a new commit message for it. So shared ID map, fix typo in comment, and that should be fine. So just send us through. Do you want yes? Okay, I think that should have generated the right commit. Yep. Okay. Cool. So that's one thing fixed. I'll just those kind of tiny typo fixes just go in whatever branch I'm working on. I don't really bother creating a separate pull request or anything for them. So it's gonna go in the same branch as the one doing the SCSI support, the virtio-blk support. Alrighty. So for this one, I think the easiest is gonna be just look at anything we've done for NVMe. And effectively just try to replicate it with virtio-blk and see if things work. So I'm trying to remember what the right search thing is, this one. So do NVMe, and that gives us a bunch of examples, well, a bunch of files that are using that code right now. So the first thing we want to do, because this is going to be a new, technically it should need its own API extensions, we should probably start with that. As a reminder, API extensions are effectively something we put in place in Incus every time we add a new config key or a significant value to an existing config key. In this case, it makes sense for downstream consumers to be able to figure out whether Incus supports virtio-blk or not. So having a new one of those probably makes sense. To do that, there are two files we need to edit. So it's in, I think I can actually do it with, how do we find a file? Yeah, there we go. So if we just look for API, there's API extensions markdown, so that's one. And the other one would be api.go in internal version. So the first thing is we just need to pick up a name. So we can see here that disk IO bus was the one that introduced the feature. So let's just do a disk IO bus virtio-blk. It's a bit long, but whatever, it's fine. So that's our new API extension string. And now we just need to go in the other file, and it's simply adding a description for it. So that, and that's a new, and I don't actually remember what I called the virtio-scsi value. I don't remember if it's just scsi or virtio-scsi. So let's look. Virtio. Okay, there we go. That's the documentation file. And we can see that the current values are NVME or virtio-scsi. So that answers my question, which means for virtio-blk, we should call it virtio-blk. So add the new virtio-blk value for io.bus on disk devices, which allows for the attached disk to be connected to the virtio-blk bus. It's very repetitive, but anyway, I'll just do a bit of wrapping here, and that should be that. So save that file, save the API Go modification, and let's go and commit this stuff. So we can see two files. The new thing is new API extension, save that, commit. And if we look, that should show us what we want. So it adds the new chunk. No new line at end of file. Yeah, I don't like that behavior of VS Code. I should probably do something about it at some point. Let's see, did it do the right thing now? Yeah, there we go. No new file. Seriously? Fine, because I think VI will do the right thing. I'm sure there's a simple setting I need to just change for that. Again, not the biggest VS Code user. There we go, all fine. Cool, all right, so that's that initial commit that just adds the API extension key we need, all good. The second thing we'll do is just the documentation commit, so that's another trivial one. We can see here, the description shows io.bus, virtio-scsi. It's not required, only for VMs, and override the bus for the device, virtio-scsi or NVMe. So we're just going to be adding, and they're not in a particular order right now, so let's fix that. So let's do alphabetical order. So NVMe, virtio-blk, or virtio-scsi. Okay. So that's that. Then commit that as doc and virtio-blk as option to io.bus. Okay. There we go. So that's most of the kind of boilerplate stuff done. So we've got the API extension in place, got the documentation in place. I don't think we need, let me just recheck, because we can see earlier what else that string is in. And yeah, there's nothing that needs to be regenerated or anything. Okay, so we're good. Now what we need to do is actually make it work. So what I'll do is actually look again for NVMe. We can ignore all of that stuff here, ignore that's the documentation. Where's that one? That's in C group stuff, doesn't matter. This one does matter. So that's the validator that checks what options are valid as far as the configuration. So again, we need to change that one. So let's do the same thing with the alphabetical order. So we do virtio-blk and virtio-scsi. Okay, that's easy enough. And the rest of it is apparently all in driver QEMU. So we can commit that file on its own. There we go. That would be Incus D device disk add virtio-blk. Okay, commit down, and that's that file done. And then we've got the possibly last place we need to change. And I realize it's a bit optimistic of me. Like I'm literally just doing all the changes, hoping that things just behave. I'm not completely sure that that's going to be the case yet. But this should be an actual easy change. Like I said, like we've got a bunch of those issues on GitHub that are marked as easy, and some of them really are easy. I'm kind of hoping this one is one of those. That would be nice. So let's see. Driver QEMU. So this guy. So that's going to be maybe a bit more logic in there. Right, so it shows if bus name is NVMe, then we need to do the PCI allocation. I think this is going to need to change, and we need to do both. So we've got I think it's in utils, and we've got value in slice. Yeah, there we go. Okay. So if bus name is in a list of both NVMe and virtio-blk, then allocate the thing. Just trying to explain what's going on here. We're going to be trying to attach the disk directly to the PCI bus as its own device. This is not necessarily ideal if we were to really want virtio-blk to be like a first-class supported thing. Instead of each disk attaching to its own PCI address, we would want to have a fixed virtio-blk controller that's attached somewhere like more towards the root of the PCI tree, and then have all of the disks attached to that instead. That would be closer to what we do for virtio-scsi, which is our default. The problem with that is I don't really want to add another default controller out of the box, and this is more of an opt-in feature, so I don't really mind if that effectively causes more PCI addresses to be used on that particular VM. It shouldn't really do anything as far as like impacting performance or anything. It's going to be using some PCI addresses. So if you would start attaching dozens of drives, you might start running low somehow. I don't remember. My knowledge of PCI is quite limited. I don't remember exactly how many PCI root addresses you can actually use at any one time. It might be something like 256, at which point it's not really a problem anymore. Could be something lower, like 64 or something, which might make it more likely to actually run out of. But anyway, I don't think it's going to be a problem for pretty much anyone. And if it is, then we can start looking at doing something where like the first device you attach gets you a controller, and then everything attaches to that controller. But that's always a bit tricky with the old hot plug, hot remove stuff we support. So gonna try and keep it nice and easy on this one. So the check has been changed for NVMe. It shows allocate PCI port and write to config, can hot plug the drive. So we're just gonna be removing the NVMe here. I'm just gonna do a drive since we do both now. And after that, there is another check here for NVMe. So again, if it's virtio-scsi, it attaches to the existing SCSI bus. In this case, it is not virtio-scsi, so I need to do the same change with utils.string in slice. And bus, not string, is value in slice, sorry. It used to be string in slice, but now with newer Go, you can actually do functions that take any type. So we've just done we used to have string in slice, int in slice, int64 in slice, all that kind of stuff. And now we just have a value in slice. It's much simpler. So here we can take bus and just do the string. So again, we'll do NVMe first and virtio-blk as the second value. Oops. Okay. Next, what else do we have NVMe in this stuff? So that's the first one we did, second one we did. Here there's like using PCI, so it's in that chunk. Using PCI bus device to hot plug NVMe into, so it will be drive now. So just removing a mention of NVMe. And then there is here the driver. So if we make it to this part, So we've got, we know that we've got the bus that's NVMe or virtio-blk. I think we can just change the driver to being the bus actually, and that should do what we want. So let's try that. And see if this builds, because in theory, that's all we need to change. It actually just kind of makes some of the NVMe code slightly more generic now. So if we need to support something else down the line, we could. Okay, so there's an error line 3949. What do I do in here? Oh yeah, okay. Just forgot to close a bracket, so that's easy enough. And it's complaining about utils. How come we don't have that? Or is it util? I'm probably just messing up the name because it's almost impossible that we didn't import it already. Just go look at the import. It might just be util. I think it's just util. Yeah, it is. Okay. Alright, so let me find those two and just fix them up. I mean, VS Code was yelling at me, to be fair, but I'm not used to VS Code and I don't actually care much about its yelling. So that should work better. Okay, so this is building fine now. And then we need to test it. So it's all built. So I'm gonna switch over to a terminal. I'm gonna become root. Actually, let me just split that terminal in half. There we go. I'm gonna be root on the second one. Okay. And what I do is I actually end up moving the binary just over the one coming from the package. Restart Incus. So we can wait for it to come back. Should just take a few seconds. There we go. So now we're running on that local build of Incus. I've got a bunch of stuff running here. I don't think I've got anything obvious I can just use for testing. Been doing a bunch of oven stuff recently, as you can see. I think I do have a spare volume for testing. So if I go look here, yeah, I do have a volume called foo, which is going to be fine. So I'm just going to launch a new VM. Let's do Ubuntu 22.04 as a VM. Might as well start with the hard stuff. So I'm going to try boot up the VM and then actually hot plug the new device straight into it. Probably not the easiest thing to start with, but if that works, there's a good chance everything else will. So let's go in there. Okay, that VM is running. The list of blocked devices right now shows just the normal virtio-scsi stuff, nothing else attached. Okay. So let's try and hot plug this thing. So VM is v1, we'll call the device foo, it's a disk, its pool is default, and the source is, so the volume name is foo. If I do that, it should just show up on virtio-scsi. Yeah, SDB, fine. Now remove it, might as well retest everything. So if I remove that, it's gone, we're good. Next, let's try IO bus NVMe. Make sure we didn't break that. Yep, it's on NVMe. Let's remove it. Okay, it's gone. And now for the actual try, so virtio-blk. Device added, that's a good sign. Yep, VDA, there you go. So this is actually on the virtio bus now. It shows 50 gigs, so that actually looks pretty good. I don't have G-disks, let me just install that. Just want to make sure that it looks correct. Like obviously it's an empty drive, but yeah, so it looks the correct size. There's a GUID header thing. Sector size is 512. That looks good. Okay, now let's see if removal works, because that's the other part of the fun. Okay, it took a bit of time, but yeah, it's removed. Put it back in. Yeah, working fine. So that works pretty well. Next step is gonna be to turn off the VM and just start it back up, making sure that this also works on like this also works not just through hot plug, but also during normal startup. It should be perfectly fine. The way things actually work in Incus is that on startup, we don't actually, unlike something like libvirt, which generates like a massive QEMU command line with everything passed through it, and has limited flexibility to mutate that afterwards. What we do with Incus is we start QEMU in a very limited mode with pretty much no arguments, but we just tell it, please listen on QMP, which is its control protocol. And then through QMP, we go and add disks and do that kind of stuff. So effectively, even on a clean start, the storage and network is hot plugged into it. That means when you have one code path to deal with, that's why it was so trivial to actually add this. But it's still good to make sure everything works. So it started. Let's look. Yeah, it's listed fine. gdisk is good. The other thing I'm just wondering, but that doesn't really matter, but it's mostly, do we see it from the firmware as well? So can UEFI see it? That mostly matters for anyone who's trying to boot from this. Just like NVMe, it's not going to work out of the box. If you try to straight up change the root disk to being virtio-scsi and reboot, it's not going to work. I mean, we've got time, I can show you that. But so if I shut down the VM, and then I override the root disk, and I do IO bus, and I move that to virtio-blk. Okay, and we start the VM. I'm gonna have it show the VGA console so we can see the firmware. There we go. Okay, so if I stop into the firmware, we can go see if we even see those disks. And we do. At least there's a non-block device thing here. Yeah, misc device. I think they appear. We could try and see. Yeah, so it does see GPT and everything. Okay, so that's fine. And if we continue, it's gonna try it. So it's gonna go into GRUB. That's fine. And then it's gonna try and boot. And that's the part that will most likely fail. Right now it just gets stuck on that boot logo, doesn't let me escape or anything. And what's going on behind the scenes is that our images, they actually, at least the Ubuntu ones I'm using here, mentions SDA2 as being the partition that needs to be booted. And because there's no more SDA2 now, it's just gonna fail. There's an easy way around it, and I showed it, I think, when I did the NVMe feature. But you effectively need to just update GRUB so that on the installed system, it regenerates its entry to include the GPT partition ID, at which point it doesn't matter what bus it's on and everything works. So the way you do it is like you're stuck. Eventually it will time out and show a debugging terminal, but it's just stuck here. So you get out of that, you stop it, you go and change the bus on that device again. Let's put back to virtio-scsi. This time it's gonna boot just fine. So just let it boot. Here we go. There we go, it's booted. So once it's booted, you just go get a shell and you run update GRUB. I can actually show you what that's gonna change. So if you go look at boot GRUB cfg, right now, the boot entries, you're gonna see, and it's always a massive mess the way this thing generates, but like it shows root equals dev SDA2. That's the issue. Now, when you run update GRUB, it regenerates based on the current system UUIDs, and now we see root equals UUID something. That's good. Now it means we can boot it off of anything we want. So if I go and change that back to virtio-blk now, and we start it, it should do the exact same thing as earlier, go through the bootloader, but this time it won't look up the partition based on its path, but based on its UUID, and it boots just fine. There you go. We can see here, so if I'm on the system and I look at ls-block, we can see both of the disks, so the root disk as well as the external disk are now both on virtio-blk. If I turn that off, we can just show that we can do the same mix and match. So let's change the root disk to NVMe. and then start things back up. And because of that GRUB reconfiguration, NVMe is also gonna just work out of the box pretty much. There we go. And now if we go in there and look at ls block, there we go. One thing that's actually kind of interesting to test, and we should be able to do that easily enough, if I can remember how FIO works. From my tests so far, I've seen the best performance out of at least both virtio-scsi and NVMe to be NVMe. We just can't change the default because not all operating systems handle it properly. There's a bunch of other issues. Virtio-scsi is the safest bet in general, but for pure performance, NVMe has been doing better. What's interesting here is that we've got that extra disk attached to the VM. Let me actually remove it. So if I remove that disk, okay. So currently the VM is on NVMe with an extra disk, but that means with that extra disk, we can add it and change all 3 buses while using the exact same device, exact same size, exact same data, which then makes it easier to do some amount of testing with something like FIO. Now I'm the first to admit I have no idea what the right FIO arguments are to do those kind of tests, so I always end up just Googling for it. There's been some pretty good tests done as far as the benchmarking by the Ceph guys, so I tend to kind of go for that. So FIO Ceph RBD, I think that should find the. There's a blog post, I think. Performance analysis, FIO and RBD. Oh, this one is on the Ceph blog. I think that's the one. No, that's not. Ceph performance testing. Maybe this guy. Was it this one? Might have been. I don't remember. Anyway, let's see. Do they have? No. Oh, there we go. I mean, this one shows I read it already, so that's probably the one. So they did a bunch of tests, but they also happen to have the. I think they had the incantations for FIO, didn't they? Maybe not. Okay, fine. FIO block device test some with typo. Google can figure it out. Sample FIO commands for block volume performance. Sure, why not? Let's try that. Okay, throughput performance test. I don't really care about IOPS right now. Let's just try throughput, and let's try something kind of hard like random read writes. So that's a file. Is that through a block? Yeah, it is. Okay, excellent. So we want that. Test random read writes. Okay. So copy pasting that in. File name would be where this thing is attached. So currently we don't actually have anything. Okay, so just let it fail. But so let's try with virtio-scsi first. So I'm going to be adding that one, and we'll do virtio-scsi. So go in, do ls block, and we see it's at SDA. Be very, very careful about the name of the file you're passing, because it's going to literally wipe your disk if you do it wrong. In my case, it's a test VM, I don't really care, but yeah, you still want to be careful. Okay, so it shows read 700 something megs, write 600 something megs. I didn't actually check what the time is. It's 2 minutes. Yeah, that's too long. I'm not gonna do 2 minutes. Let's do 30 seconds. I think we can wait 30 seconds. Oh, the other thing I should do first. So let's shut down that VM. Let's remove the disk, because I want to always do a hot plug to do it the same way, but I'm gonna bump the specs on that VM significantly. So let's do actually 8 CPUs and 8 gigs of RAM. I just don't want the CPU or memory to be the bottleneck in those tests. So bumping the resources, I mean, not crazy high, but reasonably high would be good for testing this. All right, so it's booted. we shouldn't have any disk now. Cool, adding the disk. There we go, and let's run FIO on it. It's got the time at 30 seconds, so that should be fine. Let's try now. Okay. Also keep in mind, this is running on my desktop machine while I'm literally live streaming, recording, everything. So not like if I wanted better numbers, I would probably run that on, I've got an AMD Apex server in the basement I would probably use for that kind of testing with like enterprise grade drives and all that kind of stuff. But for just a basic, let's do the run with multiple types of drives and see if we notice any obvious performance difference, that's pretty good. Okay, so that was virtio-scsi. Let's just remove it. And we'll do virtio-blk next, and then we'll wrap things up with NVMe and then look at the actual numbers. So now it's virtio-blk, so it should be on VDA. Yeah, VDA exists, so let's run that. So far, it looks like the values are slightly lower. We were hitting the thousands in like slightly over 1,000 earlier, and we don't seem to be doing that, at least not consistently this time around. But again, like it's not bad either. It's still, we're still hitting that 800 ish range. But we see that like occasionally we hit the 1,000 and then it just slows down immediately afterwards. Okay, so done that one. And last is gonna be NVMe. So attach the same disk to NVMe and let's do it again. Okay, I need to be careful there. NVMe 1? Yeah, 1 and 1. Okay, I almost wiped the wrong disk, so again, need to be very careful. Alright, so on NVMe, yeah, it's not that different, is it? I did see better performance last time I tested it, but this looks very, very similar to virtio-scsi so far. But again, like the speed is so good in all cases that it's not really something you're going to be noticing all that much. Okay, it's done. So, reading the results of that stuff is always interesting, a bit of a mess, but okay. So we're looking at, say, the speed down there, so we can see the bandwidth in kilobytes here, max, min, max on both read and write. So this shows a max speed of 1,464 for writes. Max speed for reads was 1381. What probably matters more is the average. So we were looking on NVMe at an average read speed of 783 and average write speed of 800. And it's doing the two at the same time. So 783, 800 on NVMe. Now if we go look for the same here on virtio-blk, we're at 753, 759. So it's pretty symmetric, at least in this case, but also lower than NVMe. And then virtio-blk up here, 779, 781. So yeah, NVMe is technically faster in this particular test, but not by a lot really. The other thing that could be interesting is to figure out the latency, and that's always a nightmare to read it for me. Let's see if we can figure it out. So let's look. So those are the latency values here. Average latency and the unit can change. That's kind of the issue I've had in the past. So 43 micro, 76 micro on this one. What are we looking at here? 6277. Okay, so it's worse latency-wise on read, it looks like, on virtio-blk than virtio-scsi. And then the last ones would be 60 and 96. So this one would be one of the lowest in read, if I remember. No, okay, it's not. Yeah, so NVMe would actually show a higher latency in this case for some reason. And the unit is the same, it's microsecond in both cases, okay. Because some of them do change occasionally between microseconds and milliseconds, and it gets really confusing. There's also the IOPS value, so that could also be interesting to check. So average IOPS on NVMe for read and for write. So 3059, 3126. On SCSI, we were at 2942, 2966, and on block, sorry, that was on block. On SCSI, we were at 3044, 3050. Yeah, so that shows that virtio-blk is technically the slowest of the bunch. Virtio-scsi would be second fastest or fastest, kind of depending on the latency thing. And then NVMe has the highest throughput, and also like latency-wise, it doesn't look quite as good. But again, this is running on a busy system, running a ton of other stuff, so that can always change. It's something you might want to just retry. It shows that all three are technically pretty good. There's no massive performance difference between them. One thing that was interesting, I think, with NVMe was that the kind of CPU overhead in the guest was generally a bit lower than with the other two. Also, it's got kind of wider support. Like you can just natively run it on Windows and it just works, that kind of stuff, which is kind of convenient for NVMe. Anyways, that shows that the code actually works perfectly fine, which is great. So if we can actually go back here into VS Code, I can just look at delta, we've got this, I can just do, at this point, commit this stuff. And that's gonna be Incus the instance QEMU, add virtio-blk support, save that. And this should actually close the GitHub issue. Oh, that's right. It actually does the complete for the issues too. That's cool. Virtio. Yeah, add support for virtio-blk as an IO bus. Yeah, that one. Okay, cool. So let's do that. And that should be it. Let's go back to the terminal. I can look at the code. Let's see. Because okay, so there's no more diff here. I usually just run another Go format to make sure everything's clean. It is. So if we look at the commits from today, there was the commit to fix that tiny typo that's currently causing our test to fail, so that's fine. Then there is the, actually let me do the split screen here. Incus. Then there's that commit that just adds the API extension, so there's just the description fields. It's fine. Then there was the documentation one, so that would be this guy. So it just updates the valid values in the documentation to include everything that's supported. Then here we've got just adding the new bus to the valid values for the disk device. And lastly, the actual change to support it, which was far easier and unexpected. If anything, we're modifying more comments and log entries than we do actual code, which is simply add a new bus, virtio-blk. Virtio-blk is also the name of the driver, so we can just pass in the name of the bus as the driver name to QEMU, and everything just works. So that's it for this one. It's going to be a pretty short stream, and things actually work at the end of it. That's somewhat unusual. I'm going to be sending a pull request for that up shortly. I'm just waiting for this guy actually to clear out. I guess I could just push it to a different branch. So I could do pushing that to VM, I think, is one of my branches. There we go. And then I just do compare. So I get the URL. Can I use just doing now? There we go. So that's add virtio-blk support for virtual machines. Send that through, and here we go. Actually, no, it's not quite right. There's a spare commit in here I don't want, because I just reused my main branch that already had a commit sitting in it. So I just removed that first commit. I'm just gonna force push, which should get rid of that initial commit now. Yeah, there we go. So we just see the typo fix and the 4 commits to add this new feature. This is going to go through testing and stuff and probably be merged later today. Then it will make it into the daily branch and everything, and it's going to be inside of Incus 0.5. That's due to be released in a couple of weeks. Just before wrapping up, I'm going to look at the chat here. I've seen a few people saying hi and just asking a few questions here and there. So just catching up on the stream, super interesting that Incus is actually using QMP. I was just reading about it. Yeah, QMP is pretty good. Actually, we do a mix of two things with Incus. So if we go look at, say, one of the QEMU processes here, that's the one thing for my current VM, V1. So we can see we call QEMU with a UUID. We tell it to demonize the CPU stuff. We've got to pass some amount of it through the command line still, so we do it that way. Then no graphic. Some of the serial stuff, we need to do it that way. Same thing for sandboxing. Not everything can be passed through QMP or through a config file yet, so we do still need to mix and match kind of what we pass through. The other thing we do is we pass that read config. That allows passing I think it's like an INI style type config to QEMU instead of passing, 50,000 arguments to the command line. So if we go look at that file, that includes a bunch more stuff. Quite a few things. So it's got a machine definition saying Q35, kind of USB layout, all that kind of stuff. The memory is configured there, the CPU is configured there. So those kind of things you can hot plug CPU in memory, but you still need something, I think, for QEMU to even start at all. Some of the other core devices are defined there, like all of the UEFI and console, SPICE, and a bunch of that stuff. But yeah, as mentioned, you won't see a storage device in there. You're going to see the SCSI controller is here, and the agent drive is also passed through there. But you're not going to see the actual root disk or any of that kind of stuff. So effectively, most of it is actually PCI, just like defining all of the PCI root port and all that kind of stuff is done through that to kind of create that PCIe tree that we can then hot plug all the stuff we want. And yeah, after that, we effectively use QMP. So we've got a Go package. If I go back here. So we do have a Go package in its internal server instance driver. So almost where we were for this stuff. And there's a QMP package in here. And this has a number of wrappers around the most common QMP commands that we use. And we then use that to communicate with QEMU to query some stuff, but also push in new devices. That's also how we drive all of the stateful, state dump, and live migration logic. It's all done through this. And they've been adding more and more stuff into QMP. I think our goal is that progressively we should be able to move more and more of our logic away from that text file and away from the command line arguments over to being QMP commands instead, to the point where like pretty much everything should be in there. It's getting better with every QEMU version. The problem is that we also kind of want to support some of the older QEMU versions, so we can't just very actively migrate to it. But we kind of do every time we want we want a new feature to be like hot plug, then we go straight to QMP effectively. So that's how that stuff works. Due to Incus looking for a suitable host OS to set up on. Yeah, there's on that side, we've got a bunch of options now. The install instructions have a variety of different distros that have packages for Incus. I myself publish a package repo for both Debian and Ubuntu, so that's Debian 11, 12, and Ubuntu LTS, so 2004 and 2204 currently. But you can also find native packages now in Arch, in Gentoo, in NixOS, and there are upcoming packages, I think, in both Alpine and Void Linux that are being currently worked on. And there is a Copper repository as well, where we also have those instructions in our getting started for Fedora. So you can pretty much pick whatever you want, and there's going to be some kind of version you can use there. Love Incus, I'll start using it all the way. Just started yesterday, and I'm in today Proxmox user, but today Incus X Freedom is the right way. Thanks. Yeah, Proxmox does a lot that's very, very similar to what we do. I mean, even in the back when I was working on LXD, Proxmox was probably the closest thing to parity type comparison, because they also use LXC for all of the container stuff, same thing we do, and they use also QEMU for all of the VM stuff. Back then, the biggest gap was kind of on the user experience kind of UI front, but that's something that LXD UI worked on, and that we also ship with Incus. So now you've got UIs in both cases. I think the main difference really is that Proxmox is also effectively a Linux distribution, so you install it directly, whereas Incus is a package you install on top of an existing distro. That's really the biggest difference these days. Other than that, feature-wise, it's getting pretty darn close as far as I can tell. Out of curiosity, have Incus team looked into Cloud Hypervisors as an alternative to QEMU? Yeah, I've been looking at Cloud Hypervisor kind of on the side. Moving away from QEMU to something based on Rust VMM would be interesting from a security standpoint, at least. I've not looked super recently. Last time we checked, there were still a bunch of gaps around, so things like this, like all of that QMP stuff. I think there was still a bunch, like hot plug of CPU, memory, external devices and stuff was not quite as easy. And I'm tempted to say that at the time they didn't have support for things like Spice, so you could get the graphical console art very easily. So some of those, like a bunch of that Rust VMM stuff was really at the core of things like Firetracker and some of the other super thin, super lightweight VMs. Very, very good for short-lived workloads in the background. They're amazing for that kind of stuff, but they were missing a lot of more standard user-facing things like actual graphical output, simple things like agent support for copying over the clipboard and that kind of stuff. USB pass-through, those kind of things. It might have gotten a lot better. It might actually be getting pretty close to that. The other thing that we were missing at the time was some of the architecture support. Both LXD and Incus, we support running on things like PowerPC 64-bit and IBM mainframes, which are not super common architectures and that were not actively being developed or tested at the time. That said, like the reason why we've got all of that driver structure is kind of designed so we could, in theory, replace QEMU with something else, and it should be fine. So that gives us that flexibility for sure. Do you know if libvirt uses QMP as well? I think they do for some stuff. Libvirt does support some hot plug here and there. And pretty much the only way you can do that with QEMU is through QMP. So they must be using QMP for that, but they don't use it to the same extent we do. Like they don't use QMP hot plug for all of their drives or that kind of stuff. They still take that massive chunk of XML and turn that into a lot of command line arguments to QEMU. Like I would expect your main root disk to be passed as a dash drive thing to the QEMU command line. Okay, more people talking about distros, and curious if there will be any built-in dashboard capabilities, or will LXD dashboard, LXD console be the only option? We're not web designers, so currently, really, we're quite happy. So the way I've done it actually in my packaging. So if we go look at the repo. So that's for my packages. Other distros can do it differently, but effectively ship 3 different packages. I don't remember if I actually list them somewhere. Yeah, there is the Incus package itself that includes the daemon. There's Incus client that provides the command line tool that you can install independently from the daemon if you just want to talk to remote servers. And there is that Incus UI canonical package that brings in the LXD UI to Incus. Now, the packaging there is intentional. The idea is that we can also package anyone else's web interface if they're interested and they put in the work to make it work nicely with Incus. So the idea is that you should be able to apt install Incus UI something else. Those packages would conflict with each other, so you get to pick whichever one you want. So that's currently the way we're doing it, because again, we're not web developers. We're quite happy with the work that the LXD UI team's been doing, and we just reapply it. For anyone who hasn't seen it, you can go, these things you can go on our online demo, just start a session there. And then you can click try web UI and you get to see what that looks like. So that's the rebranded LXD UI, which was up as Incus UI, and you can manage everything through there. That kind of just works out of the box. It's fine. The other thing for kind of dashboarding and things would be on the KPI side. So that one, not on KPI, on the metrics side. So integration with like performance dashboard, that kind of stuff. So for that, we do support integrating with both Grafana and Loki. So that's all in the documentation. If I open this here and we look for, I think, Grafana probably, that should show monitor metrics here. So it shows we've got a metrics API with a bunch of open metrics type data. You can configure Prometheus to scrape all of that stuff, and there are instructions here. And once you've done that, you can then set up the Grafana dashboard, which takes in both the Prometheus endpoint as well as Loki and gets you a dashboard. I think there's a separate page for how to configure Loki itself, or it's just in the server configuration. I think it's just the server configuration. So there's the config keys on the Loki side. So Loki effectively receives all of the logs that allows for Incus to push not only the actual internal logs of what's going on, but also those lifecycle events that tells you what your users have been doing. And it also allows streaming firewall rule hits if you're using Oven and you've configured some of your firewall rules to trigger logging. So that lets you stream all that stuff into a single endpoint, and then you can easily go see like per project what things kind of look like. I'm not sure that mine still works. I've not touched it in a long time. Actually, that's not to the point where I don't even remember the URL for it. So I do have Grafana, and let me see, Incus. Does that work? Okay. No, it doesn't. Most likely because I moved from LXD to Incus, and this dashboard's probably not configured to look at the right data sources yet. But this is the dashboard that you would normally get with actual values. The logging stuff would be at the bottom there, and you get to filter per server or cluster you're running, and then per project, and you get your top 5 for who's consuming resources effectively. So that's kind of more the overview of what's going on, and then the UI is really on actually creating stuff. So, you can go and create things. You can browse images. I don't know, let's do Alpine Cloud, this thing, sure. And then do create. And then you get to see actually what's going on. It downloads and packs and starts the thing up. Here we go. And yeah, you get to access the, it's not started yet. Okay, so you get to access the console, you get to access the terminal, you get to really kind of interact with the thing directly from there. Actually, the terminal seems to have some issues today. That's odd. Sure. Yeah, there's something wrong there. But yeah, you get to manage effectively your Incus deployment that way. I think I can connect to my local one too. Hopefully that works. I haven't tried it recently. Yeah, that's not working very well. Let me see from a incognito session if that works better. So it uses, in my case, it's connected to central authentication too, which makes things slightly more fun. One-time code for Keycloak. Where is that one? Oh, it must be this one. There we go. Yeah. Okay, so that should let me log in. There we go. So that's for my own desktop with the UI running here, so we can see the same set of VMs and stuff. So V1 is the one I used in this live stream. Can see its resource usage, what it's attached to for networking. The terminal here works properly, so you get to actually interact with the terminal if you want. On the console side, you can get the text console or graphical console. So if you were to like restart the VM, that's gonna disconnect the console, obviously, but there we go. You can see it boot exactly as you would on the command line. So this works pretty darn well. And as I said, there are other alternatives. This is the one that Canonical makes for LXD, which we just cannot take and remove a few things, tweak a tiny bit, and just rebrand. It also works on like more complex stuff. Like I always like showing Windows because you actually do get the dual desktop stuff going on. But yeah, like you have it work pretty darn well. It does support multiple projects, so we can see here I've got 3 projects set up, and you can also do like the old storage config, network config, all that stuff. So that works pretty well, and we're quite happy with it. No intention of us starting to get into web development at this point. Let me just check anything else in the chat. So distro talk around the dashboard stuff. Incus user meeting recently, yeah. And yeah, we had the first Incus user meeting earlier this week. There were quite a few people that joined. I think in total more than 20 people said they would join. Not everyone ended up coming, but yeah, it was quite interesting to get to meet everyone and kind of ask them, you know, what they're doing with Incus. So that was here the first Incus user meeting. I don't have a date yet for the next one. A few people asked. I don't know yet. Mostly I was planning initially on doing it kind of monthly, but in a month it's going to be around FOSDEM time. I will be in Europe. So I'm probably going to be meeting a bunch of Incus users at FOSDEM, even though I'm going to be running 2 dev rooms, so I won't have a ton of time to socialize, sadly. But I think I'll do another online Incus user meeting shortly after I'm back from Europe, so maybe second week of February or something, I don't know. And I think that's going to be a wrap. I mean, the pull request is up. There is no failure so far. The dual test run takes about an hour, so it's going to take a bit longer for it to be all clean. But that's looking good. It was a nice and easy one to implement for once. No weirdness, no nothing. And got to go over quite a few more things around like how virtual machines work and some of those details. So thanks a lot for everyone for watching. Thanks for the nice comments and feedback in the chat. If you've got any questions, feel free to leave them down in the comment section below, or you can go on the community forum and chat with us there. And yeah, I'll see you in the next one, probably next week. And stay tuned for Incus 0.5 in 2 weeks from now. Thanks for watching. Bye.